Hello everybody. In this video, let us discuss about NAT versus PAT. NAT is called as Network Address Translation and PAT is called as Port Number Address Translation. But before discussing NAT and PAT, first of all, we have to understand what an IP address is, what an IPv4 address is especially. So in order to discuss about them, let us go over here. So IPv4 address. So a valid IPv4 address will be having 4 nodes. So it will be having first node, dot second node, dot third node, dot fourth node, likewise. Okay, so this is the particular format of an IP address. We'll be having 4 nodes and each node will be having a maximum of 3 digits. That means it may have even 1 digit or 2 digits or to a maximum of 3 digits. Okay, so that means even this is a valid IP address or even this is a valid IP address. Okay, or even if it is IP address like this is also a valid IPv4 address, right? But again, each node will be having a maximum of 255 as the particular number. Okay, 255 only, it can always take 255 numbers. Okay, that is the thing. That means to a maximum, if you go on specifying like that, to the maximum 255 dot 255 dot 255 dot 255. So likewise we can always have, that means what, from 0 dot 0 dot 0 dot 0, which is called as loopback address. So if I go on specifying like this, we can always have 255 dot 255 dot 255 dot 255. Okay, so this is the maximum IP address that we can always have. So what do you mean by this one? This means that, so in the entire world we can always accommodate 255 into 255 into 255 into 255, which is equivalent to 4.3 billion. Okay, so these many computers we can always accommodate, because these many computers only we can always give valid IP addresses. Okay, so that is the meaning of this one. And if I say that only 4.3 billion computers worldwide, we can always have the particular unique IP addresses. But is this sufficient across the globe? No, right? So that is why an organization called IETF, right, which is called as Internet Engineering. Okay, Internet Engineering Engineering Task Force is an organization where they have divided this particular IP address, we can always say. Okay, so in 2 versions, one is called as the private IP addresses and other one is the public IP addresses. So whatever the 4.3 billion IP address we do have, they have divided into 2 things. One is the private IP address, and there is the public IP address. So that you can always use only these public IP addresses. Okay, public IP addresses as the unique IP addresses across the globe. So having said that, immediately we'll be having a doubt over here. So Kiran, so this particular 4.3 billion IP addresses, whatever you have specified right now, so we are thinking that this number itself is not sufficient, right? Again, if they segregate them into private IP addresses, some of the IP addresses as private IP addresses, how does the remaining IP addresses, which will be acting as the public IP addresses, they will be sufficing the requirement for the entire world, right? So that's why whatever the particular private IP addresses we do have, right, they may not be unique across different networks. What is that? They may not be unique across different networks. Whatever the networks in organization we do have, okay, or an organization or any different networks, they may not be unique. That means what? Whatever the IP addresses, the range of IP addresses that we define in private IP addresses, they may always repeat in the particular networks. For example, say I do have a home IP address. Okay, so I do have home network. So I do have devices such as laptop, okay, desktop, just like anyone nowadays, right? Or a mobile likewise. So for example, my laptop's IP address is 192.168.1.1. Similarly, my desktop IP address is 192.168.1.2 and my mobile's IP address is 192.168.1.3. So these are my IP addresses of my particular devices which are in my network. This is my network, some A network. So similarly, my neighbor's network, okay, besides my house, my neighbor will be having, right, in his network. He will also be having the same kind of devices, just like the particular laptop, okay, or else just like tab, mobile likewise, right? So here again, you can always have for this particular laptop 192.168.1.3 he will be having as the IP address, and for this one 192.168.1.1, and for the particular mobile he will be having IP address as 192.168.1.2. Likewise, you will be having the IP addresses. So now if you observe in this network A and network B, so the IP addresses are getting repeated. So in my network, in A network, 192.168.1.1 is the IP address of the particular laptop. So similarly here, you will be having the IP address, the same IP address, 192.168.1.1. This is the IP address of the particular mobile. Okay, so likewise, the IP addresses may not be unique across different networks. Which IP addresses? Private IP address. They have to be unique in the same network, but of course, they may not be unique across different networks. Okay, that is the particular thing. So then how does they communicate? Okay, Kiran. So we have understood. But within networks it is okay. But whenever they are communicating with the outside world, this becomes a problem, right? So whenever this particular mobile communicates with the outside world, this is his router, and if he is communicating with the internet over here, or else let me delete this one and let me draw neatly. This is the particular A IP address, sorry, A network, and this is the B network, right? And this is the internet over here. Okay, so here from A network, okay, the person is accessing with the laptop, and B network he is accessing with the mobile, where they do have the same IP address, right? That's what we have discussed, 192.168.1.2, and here also 192.168.1.2. Okay, so and for other devices he will be having, if it is having a desktop, okay, for this one he will be having 192.168.1.1. if he is having a tab over here, for this one he will be having 192.168.1.1. so likewise the IP addresses will be similar, right, across different networks. Okay, so that is the thing. So now if this particular laptop from network A has to communicate with the outside world, what will be doing? So through the router, okay, he will be communicating over here, right? So now your doubt is that because of the same reason, if this person also from the mobile phone access through the router, okay, if it has to communicate with the internet over here, so what happens? Again, there will be clash, right? So same IP address it will be having. So it is not the case. So whenever from the network, out of the network, if it is accessing the outside world, what happens? This particular IP address will be translated into a public IP address. Okay, so whatever the particular IP addresses, what are the machines that you are using, for all the particular machines you will be having a public IP address, say 53.62.31.5, and for this one, right, we will be having a public IP address 64.82.31.68. So likewise, a public IP address will be assigned. That means what? The private IP address will be translated into public IP address. Okay, so in that way they will be having a unique IP address, right? So this is the actual process that will be happening. So what are these private IP ranges, Kiran? So we do have various private IP ranges over here. If we consider this particular thing, private IP address range. So we do have starting from 10.0.0.0 to 10.255.255.255. This is called as the Class A network. What is this? This is Class A network for large organizations. This is for large organizations. Okay, so that means what? They can always accommodate 255 into 255 into 255 computers maximum. Okay, you can always calculate the number. Okay, that is the particular thing that will be happening whenever you use Class A network. It starts with the 10. This is the private IP address range, right? So, and similarly, 172.16.0.0 to 172.31.255.255. That means how many accommodate? This is called as Class B network range. And how many computers can be accommodated? 16 to 31. That is equals to 15 and 255 into 255. Right? So these many computers, they can always accommodate in this particular range of IP addresses. Okay, that means Class B IP address. In Class B IP address, they can always accommodate 15 into 255 and 255. Okay, so this is for some small organizations or medium organizations. We can always consider medium organizations. Similarly, 192.168, as in the earlier case we have taken the example, right? So starting with 192.168.0.0 to 192.168.255.255. So this is called as Class C, right? They can always accommodate how many computers? 255 into 255. This is for small organizations or home computer or home computers. Okay, so you can always have this particular Class C range. So these are the private IP addresses. So apart from this, all the other things are public IP addresses only, which are uniquely available across the internet, right? So these ranges, okay, these IP ranges, they can always be used across different networks. They may not be unique. Within the same network, it should be unique, but across different networks, they may get repeated as well, just like how we have seen in the earlier case, right? This is what we have to understand. And now, if I say, okay, so what are the particular IP addresses, okay, that are getting translated? So how they can communicate with the outside world? This particular IP address will be translated, right? This particular private IP address, which is 192.168.1.1 or 1.2, whatever it may be, it will be translated whenever it is communicating with the outside world, right, through the internet. So it will be translated to a particular public IP address, something. Okay, so likewise it can always translate it. So this translation is done by NAT, or by PAT as well. Okay, this is done by NAT or PAT also. So as we have discussed, this NAT is called as network. So this kind of translation from a private IP address through public IP address, okay, is done by the NAT. Okay, so network address translation, or PAT means what? Port number address translation, right? So this is the particular thing. So how it will be translated, Kiran? So whenever, okay, so again whenever I say NAT, right, this will be happening through NAT, we have discussed it, right? So this will, whenever it is transmitted through the router, okay, we'll be having a NAT table where the particular list of IP addresses, okay, here we'll be having even other devices as well. My computer, my desktop will be there. Okay, this IP address is what? This is 192.168.1.1. Okay, so likewise all the IP addresses will be listed over here, and the public IP address it will be taking, it will consider the public IP address accordingly, and it will be allocating the particular public IP address. Okay, that is what happening from the NAT table. So whenever we consider NAT, we do have two things over here. Again, one is the static NAT, we'll be saying. Other is the dynamic NAT. So what is meant by static NAT, Kiran? So static NAT means one-to-one assignment will be happening. That means, see, I do have different computers over here. Okay, I do have different computers. This is my tab as well. Okay, so whenever I do have different IP addresses over here, 192.168.some1.3. So for these particular things, okay, only one public IP address will be assigned one to one. Okay, so for example, this is the public IP address that my organization will be having. So it will be allocated only to one thing. Okay, for this one, it will be translated. But what about the other things? Right? So that's why in static address only one to one assignment. One to one assignment will be happening. So if at all, that means if at all my organization has taken only one public IP address, it should be assigned only to a particular private IP address, to one computer, to one device. If at all, it has to be, again, if it is communicating with other networks, or if it is communicating with the outside world, what happens? Again, a new IP address has to be enabled. So which is of no use, right? Again, what is why we want to minimize the particular public IP addresses. So that's why we are using this particular translation. But again, if for this one also, okay, for this one, again, we have got this one. For this one, again, if you want to take another IP address, 54.64.32.2, for this one, 53.64.32.3, like this, if you want to take for each and every one, again, a public IP address will be allocated, which is of no use. That's why, right? Okay, so the static NAT, okay, with one IP address, with one public IP address, we cannot suffice the requirement, and at the same time, we can also not accommodate different public IP addresses to different private IP address to different devices. Okay, so that is what. So then the dynamic NAT comes into picture. So what does this dynamic NAT will be doing? This particular dynamic NAT will be there, right, in the particular NAT table, in the particular whatever the particular IP address we do have, yeah, or else in the NAT table, right, 192.168.1.1, 192.168.1.2, 192.168.1.3. Okay, so in this particular, what are the devices that you do have in your network? For all these particular devices, in the pool of public IP addresses, dynamically, okay, so in the pool of public IP addresses, 53.64.32.1, 53.64.32.2, likewise, okay, whatever the pool of public IP addresses will be there, dynamically it will be allocating as the particular IP address. It will be translating into the particular IP address, public IP address, from private to public IP address, it will be translating, so that the entire network will be using this particular IP address. Okay, so this is what dynamically it will be allocating the particular public IP address. This is what it will be happening in the dynamic NAT, whereas in the static NAT only one-to-one assignment is possible, which is not so useful. Okay, that's why mostly dynamic NAT will be is the technique that will be used. Okay, so that is the particular thing that you have to consider. And there is another technique, as we have discussed, which is PAT, right? PAT, which is called as port number address translation. So what does this port number address translation be doing, Kiran? Let me delete this one. So PAT, if I say, so here, what are the particular IP addresses we do have, right? 192.168.1.1 private IP addresses, 192.168.1.2, 192.168.1.3. Okay, so for each private IP address, okay, it will be allocating the public IP address 53.64.32.1, right? 53.64.32.1. Okay, here also 53.64.32.1. This is the IP address that we are allocating, but on different port numbers. Each and every computer, okay, each and every computer in your network will be having the same public IP address, but with different port numbers. Say 6001 is the particular port number. Okay, for this one, okay, 6002 is the particular port number, and this one 6003 is the particular port number. Okay, so likewise it will be allocating. So how many, now there is no limit, okay, how many computers you can always accommodate in your network? So many computers. Again, if any new computer, if we add over here, okay, again you will be having 53.64.32.1 with a different port number. Okay, so likewise we can always allocate. So this is the difference between NAT versus PAT. Okay, so NAT versus PAT. NAT, it will be by network, by using network, it will be either statically or dynamically. Okay, by using network, it will be either statically or dynamically allocating the public IP address. Public IP address, that is right, that is what important. Public IP address. Whereas NAT, right, by using the port number. By using port numbers, it will be allocating the public IP address. Public IP address, right? That is what you have to understand, right? So this is the case for IPv4 addresses we have discussed, right? So similar we do have nowadays IPv6 as well. Okay, IPv6 not full-fledgedly, but some ISPs, okay, and again some cloud service providers. Okay, cloud service providers, these people are using this IPv6 address, which is a better thing actually, which is always a good thing, because in IPv4 address, right, we can always have a maximum of 4.3 billion, right? That is what we have discussed. And again, this is 32-bit only. Each node is an octet. Okay, 8 into 4, 32-bit only. Whereas here in IPv4 address, right, we will be having how many billions, you know? 340 decibillion we will be having. 340 decibillion. This means, this indicates that this is equal to 340 into 10 into each decibillion will be having 36 zeros billion. So each decibillion, one decibillion equals to 1 followed by 36 zeros. Okay, so this is the particular stuff. Okay, so these many, that means practically infinite. Okay, so practically infinite number we can always have, but full-fledgedly it will be taking more time anyhow to implement the IPv6 addresses. Okay, not in the near future, but some, as we have discussed, some IPs, some ISPs and some cloud providers, they have started utilizing this particular IPv6 address as well. Okay, so but now, okay, but in the near future a combination of both the things will be existing only. Okay, so this is the particular thing that we have to understand, right? So this is the particular NAT and PAT and its difference, right? This is a good important question as well. So please like, share and subscribe the channel so that it will be useful for others. Also, for any kind of training requirement in cybersecurity and its associated tools Splunk, please contact on the number provided in the description. This is all in this particular video, and again we'll be meeting in another video. Until then, have a great time. Bye bye.